everyone, today we're going to do is 6.4, how much candy can you grab? So can students with a larger hand span grab more candy than those with smaller hand span? Today we'll investigate this question. So when you initially hear the question, what do you think? I would think that, yeah, people with the bigger hands will grab more candies, right? So measure the span of your dominant. I would love to do this one with you. Like, just know that, but since I'm not with you, I will just do it by myself and a special guest. Measure the span of your dominant hand to the nearest half centimeter. Notice we're using the unit centimeter. Hand span is the distance from the tip of the thumb to the tip of the pinky finger on your fully stretched out arm. So, our special guest today is actually my daughter. Say hi.
Hi.
Yeah, I'm not going to show her to you. So there is let's measure her hand spans. Yeah, spread your arm, spread your arm, there you go. All the way, spread, make it bigger, make it bigger, make it bigger. Down. Okay, so her hand span is about 13.5 centimeter. 13.5 centimeter. Oh, I'm writing it down here, which you're going to get a different one with your hand, obviously. Use the same hand to grab as many candy as possible from the container. You must grab candy with your fingers, okay? Pointing down, no scooping, and hold the candies for 2 seconds before counting them. After counting, put the candy back into the container. Okay, ready? Alright, so there are, hold on, there are candies that we have. Guess where we are from Halloween. Alright. So Gia's going to put her hand in. Yeah, you're going to grab it as much as you want and then hold it for 2 seconds and you put it down. Okay, ready? Grab it as much as you want. So you can just speed it up. Alright, 1, 2, perfect. Put it down. Okay, so let's count. How many do you have? 1, 2, 3, 4, 5, 6, 7, 8, 9. Nice. How many candies do you have?
9.
9 candies. So she has 9 candies. Okay? I'm supposed to have a class data, but I don't. So give me 1 second. I'm going to go ahead and make up some numbers, more realistic one. And then we are going to go ahead and sketch that on our website. Okay? Okay, so I came up with the data. There's my daughter's 13.5 centimeter hand span. She grabbed 9 candies. Someone with a 17 centimeter of hand span grabbed 13, and so on. So these are all the data that I plugged it in. Remember, this website is the one that we used the last class to calculate our things, to graph things. So after I put everything in, I hit begin analysis. Then this is a scatter plot that I got, which is what I need you to plot in your paper. As you can see, I know you can't really see it over here, but I actually pause the video and try to copy those things down. So why don't you pause this video, and I need you to copy these points down, which I know it's kind of hard to see. So either you can pause it here, or you can use these numbers are up there to use it. Okay, so go ahead and make sure you have this scatter plot drawn on your graph. Okay, assuming you did that, it doesn't have to be exact. If you go to the bottom over here, there's a calculate least square regression line. So if I click that, what it does is that it's gonna draw a line, right? That's a line, a linear graph that fits my data the best. It's also called a line of a best fit, this line right here. And your website also tells you what that equation is, which is right here, and we're going to write that equation down on number 5. Okay, so what is that? Y is equal to negative 9.95. I'm just going to round it up to the 100th plus 1.39x. Okay, negative 9.95 plus 1.39x. I forget I guess I forgot to answer number 4. Describe the relationship displayed in the scatter plot. So when I look at the scatter plot, I guess I can do it on the screen over here. Like, how would you describe this? Notice that it kind of looks like as your hand span gets bigger, you're going to grab more and more candies, right? So let's write it down. As hand span increases, the number of candies goes up. And what does that look like? Kind of looks like a line, linearly. Cool? And you know, back in Algebra 1, when we learn about line, what's the equation that goes with it? You all remember? It is what? Y is equal to mx plus b, where m is a slope and b is the y-intercept. Remember that? M is a slope and y is a b is the y-intercept? Yeah. So you can come up with such a line for this graph, but when we come up with that, we have what? Y is equal to negative 9.95 plus 1.39x. Well, does it look like it's in the same order? No. Why? Because the x is over here and then the constant is here. So that might look a little confusing to you. So you can rewrite this as 1.39x minus 9.95, where the slope is 1.39 and the y-intercept is negative 9.95. But usually in statistics world, that's how we like to just represent it in this way. Y-intercept first and then slope. Okay? Since this is about candies and handspan, I can also rewrite this in terms of the candies and handspan, right? So what was your x values? My x values are the handspan, right? So instead of x, I can put the handspan. So 1.39 times handspan plus negative 9.95 is equal to, what was the y? What was the y value? Y value is the number of candies. So candies, there you go. So that equation right here fits the situation that we are dealing with, correct? Okay, so I'm going to pause the video and then go back to the full screen of the papers here. Okay, there we go. So number 9, what is the slope of the line? Interpret slope in the context. So over here, the slope for our line was what? The slope was 1.39. So slope was 1.39. What does that mean? That means for each centimeter of the handspan increase, that's how much more candy that a person is going to grab. Okay, so slope is 1.39. What does that mean? That means with each additional centimeter of handspan, the number of candies grabbed go up by 1.39. Because that's what slope means, right? For each x increases, how much does y increase? In other words, for each handspan increase by centimeter, how many more candies a person's going to grab. So that's what this means. So really, for this skill, what you need to do, remember, is what does that line mean? What does the slope mean? What does that y-intercept mean for the line of the best fit for the such data? Okay? All right, number 7. What is the y-intercept of the line? Y-intercept of the line was negative 9.95. Usually, what does y-intercept mean? Y-intercept means the y value when x is 0. In other words, the number of candies when handspan is 0. But folks, can you have 0 centimeter of the handspan? No, so really that's just a useless data for here. But what does that mean again? That means number of candies grabbed when handspan is 0. Cool? Okay. Next page. Now let's summarize what we've been doing. Alright, All right, there are two important ideas. Important idea number one is called the scatter plot, which is what we just drew, right? There's x-axis, there's a y-axis, there are a bunch of data dot there. That's the scatter plot. For the scatter plot, you need two numbers, right? For our example, it was the handspan related to the number of candies grabbed, right? And we put the handspan here because that's what we are questioning. What, depending on the handspan, how does number of candy grabbed? So the handspan can be the explanatory variable, and number of candy grabbed was the response. So the x was, I don't need you to tell me anything. Explanatory. All right, give me 1 second. Okay, sorry about that. So yeah, explanatory is the x. Usually the response is the y. That's how you can think about it. Explanatory is what used to predict. In other words, the input. That's another way you can think about it. Response is the outcome. It responds to explanatory output. Okay, all right. The key point number 2 is the line of best fit. So what is that? That's the line after you've got your scatter plot. It's the line that describes all your data the best. That's how you can think about it. Usually, this is how we write it. Y with the hat on equal to A plus BX. Notice, remember, it got flip-flopped where the slope and the x goes to the second, and then the number goes in the front. And the y hat, that means the predicted. That's over there. And A was the y-intercept. B was the slope. Okay, so what was the y-intercept again? Y-intercept is the usually y value when x is equal to 0, mathematically, right? For this context, what does that mean? This is the predicted y value when x is equal to 0. What about the slope? What is the slope? Slope is for each additional x value, the predicted y context increase or decrease by slope. Which sounds kind of weird, but on the previous page, just quickly a review. If you remember, our slope was 1.93. So what does that mean? That means for additional x value, for additional centimeter of the handspan, the predicted y value, the number of candies grabbed, goes up by 1.39. Cool. All right. Since we're on the front page, let's just make a few notes over there. So on our scatter plot, you can also note that the handspan was the explanatory value. Variable. And candy was the response variable. And over here, that was the predicted. Wow. I think I highlighted everything. Perfect. All right, now let's check to see whether we have understood. At the end of the semester, math teacher wonder if a student attendance has impacted on final exam score. Here's a scatter plot. Shows the number of days absent and final exam score for a class of 25 students. Identify which variable is explanatory and which is the response. Remember, explanatory is the what? Input. And response is the output. So what is this teacher trying to figure out? Depends on the number of days absent. What will be the final exam score? In other words, the number of the explanatory variable, number of days absent, and response variable, which is the y value, is final exam score. Describe the relationship. What does that look like? By looking at it, looks like more. Give me 1 second. Describe the relationship. It looks like the more days absent, your final exam scores goes down, right? Less final exam score. Cool. All right. So this person decided to put this scatter plot in our website over there and got the following lineup as fit. Interpret the slope. All right. How do you find the slope again? Is that the first number? No. Slope is a number that's multiplied to x, which is negative 3.5. So what does negative 3.5 mean for this? Remember, it means for each x goes up, how much does y change? In other words, for each day, for additional number of days absent, your final exam score is going to go down 3.5 points. I'll say it one more time. That means for each number of days absent, final score goes down. Why do I say go down? Because it's negative 3.5 points. Okay, what about the y-intercept? Y-intercept is, so this is a slope, that's the y-intercept. Y-intercept is 90.9. What does that mean? That means y value when x is equal to 0. In other words, final exam score when you had 0 absent. Cool. All right, perfect. Let's keep going.